Okay. Awesome. I think I finally got this working now. Let me post the link up to Blackboard real quick. And then we'll go from there. I switched it up a little bit. I now have a monitor next to me, so that's nice. So I can actually see my Pi coding rather than doing this into the webcam constantly. I don't know, maybe you liked that. Squinting is it's a really appealing look. So, but I do have a monitor now, so I don't have to, I can actually see what it is that I'm typing. Do you remember that I'm going to be monitoring the stream here, so if you have a concern or question, please drop it. Otherwise, the link to the video lecture is now on the Blackboards I'm gonna go ahead and we'll finish this. So, all right. I'm gonna go back into my code. So I'll go into the folder. Okay, maybe I won't. Why are you doing this to me, Pi? I thought we were friends. I'm gonna go into Thani, and then go ahead and open up my program from there. Apparently, my Pi is being rather frustrating. So, here's the code that I had last time. It hasn't changed. I have not touched my Pi since last we talked. One thing I did want to point out was this right here is a truth table. You input that you want the number to be 0. The output that goes to the LEDs is this. So, yeah. Okay. Alright, so when we left off last, what we had was the left number is going to be, we set up this value to pick a number 0 through 9, and then we set the left number is going to be the time %10. What that is like, let's say I were to just, I'm pulling up a brand new program here, and this is, I'm going to call this test. So let's say I have 45, should probably write it on the, I have two keyboards right now, so bear with me if I seem like a technological freak, but I kind of am. Two keyboards, separate monitors. This one's dealing with stream, this one's dealing with Pi code. If I don't go crazy by the end of the stream, give me an award. So let's say we have 45, and then I'm just going to say, you know what, I'm going to say print 45, oh, you know what, now I'm going to say number is equal to 45% 10. Okay, and then we're going to go ahead and print number. Okay, when I run this code, it's going to make me save it. I'm going to save it as in Pi programs as test. When I run this code, it just comes back as 5. Okay, so what a percent is a percent is a way of getting a remainder out of a number. It's like a divided sign, except for with a remainder. I do believe 2% is what gives you the value Yeah, nope, you can't do that. Oh, what was it? Okay, I'm gonna look this up real quick. Because I don't know, the internet is your best friend when you code. So Python percent division division operators in Python. Okay, so you've got this. This is just a standard divide by. Okay, if you hit divide 2, it returns a floor value. I don't want to give a floor value. Oh, this isn't quite it. It's not showing me the percent sign either, so no, this isn't quite it. Python division, choose divided signs. Do not want to sign up. Okay, it's the 2 divided by signs. That's what it was. So if we go this and we hit the run button, what it'll give us is it'll give us the tens value. Okay, so if we go, I'm gonna go ahead and rename this then tens, and this will be ones, 45%, 10, and then print number, comma, no, sorry, I removed number, tens, and then I'm going to add a weird space, ones, okay, it comes back as still 45, and I can even show off that this works for more than just 45. You can go with hundreds equals, I'm going to go ahead and say number because I'm going to change this up real quick, divide by 100. Number, and then we go ahead and number equals input type a number to divide. Okay, so now when I run this, it'll ask me down here, type a number to divide. I'll say 450. No, I don't want it. Let's do 842. Ah. Okay, I forgot to convert this into an integer. Got to do that. So 842, enter. Notice it comes back as, it shows 84 in the tens place. Yeah, okay. So this isn't the most perfect way of parsing out a decimal number. So maybe what we try instead is number minus hundreds times 100 divided by 10. So that'll get rid of the hundreds place and only have the 10. And then when we print, I'm just going to do hundreds, tens, ones. Okay, so now we'll type in our 842, and you'll notice it comes back 842. We've parsed out the hundreds place, the tens place, and the ones place. Okay, we're basically going to be doing that with our digital counter. We're going to take this little snippet of code, and we're going to go ahead and plug it in over here. Okay, so number on the left is going to be number, not percent, but divided by 10. What this will give us is it will give us the tens value. Okay, and then number R is equal to nums time percent 10. Okay, so the remainder of what happens when it's divided by 10 versus what's actually run by 10. Okay, now I'm going to, so this is a while loop that just constantly updates the time. And then what we will have is we will have this display out to the Raspberry Pi. So to do that, we've got to do some Gpio.outputs. Okay. We're going to need Gpio.output. And then we've got to go back and call all 14 of these pins and set every one of those 14 pins. Okay? Alright. So we'll start with left T. And then what we're going to make this is, since this is the left number, I'm going to make it number L, and then the value is going to be, let's see, what we did for our truth table was up here, we started at the top right, bottom, bottom left, top left, middle. Okay, so when we label these out, it's going to be top right, bottom left, top left, middle. That's how we're going to have to do it. We're going to keep that order. Okay, so we'll start with saying this is the 0th position from number L. Okay. I'll go ahead and copy. 4, 5, 6, 7. Okay, so then we'll change this to top right. This will be bottom right. This will be bottom left, top left, middle. Okay, and then we've got number L. This is going to be 0. 1, 2, 3, 4, 5, 6. Now, why do we start at 0? Well, the reason why we started at 0 is because in Python, the very first number in a list is referenced as the 0th number of the list. So we go from 0 to 6. Here, it's the same reason why up here, if we do have a 0 value in this, when we do our divided by 10, it's going to return a 0 unless if the counter is less than 10. And if it returns a 0, the first entry in our nums, which is our call, is going to be 0, and it will call 0 out of that. Okay, so now we've got this set up. We're going to go ahead and do, forgot to put it forgot another parentheses. So I'm going to go ahead and Gpio.output. This time it's going to be right T, number R, 0. I'm going to go ahead and copy and paste this one. 2, 3, 4, 5, 6, 7. This time I'm going to be a little bit smarter and 3, 4, 5, 6. Okay, now I change these. R, BR, B, BL, PL, M. Okay, so now we're setting our outputs equal to whatever the value of number L or number R states it's supposed to be according to our truth table. Modify your truth table however you want, but this is what this does right here is this says just output whatever that number is to the screen, output whatever the number is to the screen. Here's the number that it's set based on whether or not it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is chosen using this code right here. Okay? So I'm going to add in some pseudocode just because I think pseudocode is necessary. So this selects the number and assigns it to the left or right digit based on the time value. Okay. Here, this is the Gpio output sequence for the left numerical digit, and then down here, this is the Gpio output sequence for the right numerical digit. Okay, so this code is great so far. Picks a time, sets time equal to 90, picks the value of number L and number R based on what time is. And then it outputs it to the screen. Okay, now this is great, but there's one thing it does not do. It doesn't update the time, which that's a problem. I'm going to show you a simple way of doing it, and then I'm going to dive into a more complex way of doing it, because you know what? I have a healthy dose of self-loathing this morning. Okay, so here, updates the time value. You just want to do this really easy. Here's the way to do it. Time equals time. Well, you can do minus equals. Actually, you can do plus equals -1. What that'll do is it'll subtract 1 out of the time value. And then we need it to sleep for a second. So time.sleep. 1 second. Okay? This works. So now it'll wait 1 second, and it'll take 1 second off of the clock. How much simpler can that get? Well, this isn't entirely accurate. The issue with this is this code up here that it is executing inside of the while loop, this takes a finite amount of time to run. So the issue that you're going to have is that when it comes down here and it actually sleeps for a full second, it will have already taken some amount of time to run the rest of this code, and then it sleeps for a second. Your timer won't actually be counting down seconds. It'll be counting down a value that should be close to a second, but not a second. That is a problem if you want accuracy. If you don't want accuracy, it doesn't matter. If you're just getting a countdown timer for the sake of countdown timer, heck, we can make time.sleep 5 seconds, and it'll count down 1 digit every 5 seconds. Awesome. So yes, this is the simplest way to do it. Yeah, you could approximate this maybe by saying 0.9 seconds or 0.95 seconds for your time.sleep. I don't like playing those games because sometimes the processor speed differs. Let's say you've got this process running in the background, you got this program running, it's outputting your LED screen, and you're sitting there browsing the internet, looking for you know, the High School Musical bad lip reading. Watched that video last week and it changed my life again. Oh, okay, well. If you haven't seen this video, you really should. This is fantastic. I don't like High School Musical, but this is quite high quality. Oh yeah, okay. We're not gonna watch that. So this is one way of doing it. But let's say you were watching videos on your Raspberry Pi or doing something else on your Raspberry Pi while this is executing. That's all processor space that's being taken up. It may cause this program to run slower. It may change the amount of time. Does that matter? Maybe. Maybe it matters. But this is a very simple way of doing it. Oh, thank you. Thank you for pointing that out, Walker. Yes, okay, I have a problem. Okay. Let's say we wanted to do something a little bit more complex. There's two things that I don't like about this code. I am very particular about my coding. Oh, I'm not done with this actually. So this is all the code that we need to. I'm gonna finish this, and then we'll go back, and then we'll finish this. Okay. This will actually error out unless we put in an except. Okay, what happens in an except is if an error occurs during the code, what code do you run after that? And the code that I want to run is gpio.cleanup, which I believe, I've got it on this computer. I lost it. That's not so much fun. Okay, so Gpio, Raspberry Pi. Okay, and it'll give you some, just looking this up, Raspberry Pi Gpio tutorial. Sounds great. Sounds easy. I like easy. So far this just looks like how to prep your Gpio. I don't want to do that. I have a breakout cat. Board versus BCM. Simple code for an LED. Okay, there it is. Yep, Gpio.cleanup. Awesome. Okay, well we did everything right then. What this will do is at the end it will clean up all your GPIO pins. It should, I believe that the Gpio.cleanup actually shuts off your pins. Otherwise, if it doesn't shut off your pins, your number will be, when this errors out, your number will basically stay exactly where it is, which that's not, oftentimes not what you want. Like, I want to quit. It's still showing 50. No, that's not so good. I'm going to go ahead and run this code, and it's going to tell me all of the problems that I have in my code. Like right here, I didn't put a comma. The channel sent is invalid on a Raspberry Pi. That doesn't like my left T. My left T is channel 17. Channel 17. It's totally a channel on my Raspberry Pi. What are you talking about? It's not cool, man. That doesn't like 17. Let's change 17 to 4. See if that likes that now. Is invalid on a Raspberry Pi. Okay, that's not quite so good. I'm gonna change this to BCM. Yep. Now it did experience an error inside of this code right here, and you'll notice it doesn't show anything. It's because the way that this works is that if an error happens, it immediately jumps down to accept. Okay? So while we're trying to troubleshoot this code, I'm going to go ahead and comment this out. I will grab the rest of this code. Shift. And then hit Shift Tab. And what that'll do is it'll bring it over. Python doesn't like it when you indent things weirdly. And then I will go ahead and comment this out and the line underneath it. Okay. So now when I run it, I should be able to see my errors. So run list object is not callable. Do not call the list. Okay. So how do I pull out the, all right, well, I'm going to go to my test real quick. Oftentimes what I do when I'm coding is I make mistakes because I'm a novice. So I'm going to go in here and I'm going to do test code in an area where I can't break anything. So let's say that 10 is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I want to just print 10, and I want to print the first number. Okay. If I print this, it's going to say, once again, the list object is not callable. What that means is the method that I'm using to try to refer to the first entry, which is actually the number 1 in 10, isn't correct. I think what I have to do is I actually have to put brackets on this. Yeah, and then it does it right. So all that was wrong with my code before was I had parentheses instead of brackets. So I'm going to go back in here, and now every time I have a parentheses where I'm trying to call a list, I have to change that to a bracket. No. So here, give me that brack. Give me that brack. Give me that brack. Give me that brack. Gonna do that again down here for every one of the debugging code is fun. And other lies professors tell you. Wait, I didn't lie to you. I just misinformed you intentionally. Yes, even professors who have desperate need for haircuts also have trouble coding. I never get my code right on the first try. Some professors when they like to do this coding, will actually have the code written out beforehand. Why? Because then they can show the students the right answer. I like showing the process that I go through to come up with my code, because quite frankly, if you're coming up with a code, you're not going to come up with the right answer on the first try. So I might as well show you me struggling. Alright, now I have converted all of my called lists, which is nums, which is number L, which is number R. I've converted all of those into callable lists. So when I run this, it should just go bam. Okay, so now it's having a problem with my Alright, all of these errors right here that it's giving you, this channel is already in use. What that means is that nobody cleaned up the Gpio since the last time it was used. So technically that already had an assigned value from the last time it was turned on. And it had already been assigned a value of an output. So when it says this channel is already in use, that's a default code that Python puts out to basically say, hey, there may be another program that's actually telling this pin what to do, and you're running at the same time, you ninny. It doesn't cause a program to break, but yeah, it looks really ugly. You can shut all of these off. I like to keep them on because I'm used to them. The issue that I have here is at the very end, the issue is it says time.sleep1 is not correct. So I'm going to go in here and I'm going to go look up time.sleep Python. Make sure that I'm doing my time.sleep command correct. Okay, so here's a website that says time.sleep. And then it says import time.sleep 5. Ooh, here are questions to sleep. Yep, Linux sleep time.sleep. Sounds like a good call. Int object has no attribute sleep. Oops. So here's an issue that happened. Once upon a time, I imported time, the library, and then I went down here and I specified a big time value, time. And it came down here. I have a lot of oh, this is supposed to be a capital T. I did a big boo-boo. I named 2 different variables with the same name. I'm going to go back through and edit everywhere I have time, and I'm going to rename it to a completely distinct variable, timer. Okay? So here I wrote this as time, change this to timer, change this to timer, change this to timer, change this to timer. Okay, now I have 2 distinct variables, timer and time. So when I run this, I don't get the error message. And in fact, there's no code down here. That means my program is still running. That's a good sign, okay? Means no error. Now, in order to get out of this, I'm going to hit Control-C. It's a standard keyboard interrupt. It basically inserts an error into the code wherever the line is. Knowing that I can insert an error into the code, what I want to do is I actually want to go back and re-put in my try statement. Okay, now I'm going to hit Control C to get out of this. And when I hit Control C to get out of this, it's going to insert an error into the code, and I want that error. So I just hit Tab to tab everything over. I'll go ahead and delete out commented at the very end. When I experience an error inside of this, which is caused by me hitting Control C, it's going to go down here and execute this code. I can go ahead and also type out print the code was terminated by user, which is not always going to be true, but it will be for this case. You can do an except and then have some kind of a keyboard interrupt and then have a different except for other errors. So I think, let's see, I'm going to go up in here and then Python try except. I'm just going to look up a quick little information on how to do try and except. I'm looking mostly for the code and the keyboard interrupt, how to do exceptions. I do believe it is. Oh, I need a nice list of different exceptions. Ah, here that is. Okay, so I'm going to have the exception of keyboard interrupt. This is when I hit Control C. Okay, so we're going to make it say except keyboard interrupt terminated by user. And then we're also going to print Kale is the best future president. By the way, vote for me. I'm running for president 2050. Okay, so that's one exception. And then I'm going to go ahead and say just normal except. And then have this be Gpio Cleanup. And then print an error occurred in the code. Unity. Okay, so I'll go ahead and run this. Now, once again, I haven't actually hooked up my circuit, so I cannot tell if anything is going right. No clue. But I can tell if I hit Control C, it should tell me that I'm going to be a great future president. Which it isn't doing. Well, that's fun. Oh, I gotta do else instead. There it is. Run. Control C. Oh, come on. It's supposed to give me my keyboard interrupt. Well, I don't need that very much. And then you can do finally. Finally, it says no matter what error occurs, do this. You can raise an error. This is a really nice way of doing troubleshooting. I just really don't understand why my keyboard interrupt isn't working. Go ahead and comment these out. This is bothering me. Run. Stop. Okay, so what happens when I take out the keyboard interrupt? Run. Still not. Huh. Well, it's supposed to work like that, and it's totally not, but that's unfortunate. I have no idea what's going on in my Pi right now, because it's supposed to be doing something that it isn't. We got 10 minutes left of this video, or less. I'm going to go ahead and fix the two problems I have. First, okay, here, this problem, you may not have noticed. If the button is pushed, being pushed, it resets the time, okay? We talked about in this class the difference between rising edge, falling edge, on value, and off value. When it comes to flip-flops, it's a lot more accurate if you catch the rising edge or the falling edge because it only occurs once. Okay, with this value, if the button is on, the button may be on for multiple cycles. I may be pushing the button and holding the button on for 90 seconds. When do I want the program to detect the button push? If I push the button down, does it stay on 90 until I release? Or do I want the very first button push to be there? There is a way in the Gpio settings to actually figure out when a button is being pushed. It exists independent of the location in your code, so you can actually be in the middle of something and it'll be waiting for a button to be pushed and you can execute a code that way. That is very complicated. We will not be getting that into that this semester. Also, I need to do a lot more research on that myself. I played around with it some and I was not able to get it to do what I wanted it to do. So I won't claim to be the knowledgeable overseer of all Python knowledgeness, but I also use a lot of Google, so I've pretty much have already proven that wrong. But I do know how to do a fairly cheap method. Button, what we're going to do is I'm going to go ahead and assign a value that is button press. Okay, and what button press represents, I'm going to label this as false. This is the value of the button press in the previous iteration. Okay, so what that means is that is the last value. It's a look back value. It's to say, okay, store this value in memory and look back at it. What I'm going to go ahead and do right here is if Gpio button and not button press, then set the timer. What this does is this says if the current value of the button is being read and the previous value of the button was 0, then change this. Okay? And then right after that, I say button press is equal to Gpio.input button. Okay? So if the button is not being pushed, not being pushed, not being pushed, it starts at false, stays false, stays false, stays false. This is currently false, which means it's evaluating to true because it's not. So this is false and true. You have an AND gate where one statement is false, one statement is true. Boolean logic means that's going to come back as false. So this says if false, so it doesn't run the if code. Okay? But as soon as this value becomes true, then this is a true statement. This is still a false statement because the last cycle, this was a false, so this evaluates to false. Not this evaluates to true. True and true evaluates to true, meaning that it runs this code. And then right away, it says button press is equal to gpio.button, which means it assigns whatever value the button is being pushed at to now button press. So then the next time it goes to run this code, this evaluates to true, and this evaluates to false. So it doesn't matter whether the button is being pressed on the next iteration of the run code if the button was not depressed. Okay? Got to bring that depression into here. So that's what this code does. This detects a rising edge. I'm going to go ahead and detects a rising edge in the button push. Just gives us a little bit more accuracy, and that means that as soon as you push a button, it's going to reset to 90 regardless. Okay, doesn't matter what the timer was before, you push a button, resets to 90. Now, do be careful in here. The way that we have this code written right now is we have a time.sleep. In this time.sleep, the code is doing absolutely nothing for 1 second. So if you push a button for a quarter of a second and the system wasn't reading it because it was sleeping, it's not going to detect the button was pushed. Okay, doesn't matter whether it's this code or the last code. So the time.sleep does create a bit of an issue. And also, as I pointed out earlier, it's not fully accurate. What if we wanted an accurate time? How would we change that? Well, it's another time function. Okay, what we're going to do is I'm going to go back into here. Go back into here. You're gross. You're so smelly. All right. Yeah. Okay. No. Time. Python. It's Python time. Okay. Now I want a true time value. I'm going to go into the Python documentation. I'm looking specifically for a time value. So I don't want to use the sleep. I'm going to use local time, and I'm going to do a test run real quick. So I'm going to go ahead and say import time. I'm going to delete out this code, and I'm going to say time.local time, and I'm going to print this value. Okay, no, I can't really use that. This comes in, if you just type in time.localTime, it actually comes in and it tells you here's the year, here's the month, here's the day, here's the hour, here's the minute, here's the second, this is the millisecond, is all of that information. I don't want that. I want time in seconds. Okay, so I'm going to go in here, I'm going to say, okay, what is okay, so if you use ASC time, it gives you a string that looks like this. I don't want that. Get time, I don't know what that is. Set time, clock, C time. Oh, this converts a time expressed in seconds to an epoch time. So if we wanted to go back the opposite direction of what I'm trying to do, I don't want that. Okay, I don't want to convert to local time. That's not what I'm looking for. I am looking for how to output a time. It might actually just be time.time. I feel like I'm making this too hard now. Yes. Okay, so time.time, it will give you the time in seconds since the last epoch. And it even gives you a nice, really long decimal. That's perfect. That's what I want. Okay, so I'm going to go into my code again. And instead of doing this, I'm going to go ahead and say, I'm going to introduce a new variable, and it's going to be time 0. Okay, and I'm going to go ahead and call that begin. So begin equals 0, and then go over here, and this is going to be the time in seconds at the beginning of the button push. Okay? So here, that's great. I want begin to be an integer. You'll notice it actually comes in as not an integer. That's okay. We can convert it into an integer by truncating it. Which I'm pretty sure you can do if I go into my test code and then I go begin is equal to int time.time, and then print begin. Pretty sure it'll just truncate that. Yeah, it does. So that's how we're going to do this. We're just going to truncate that time. Okay. So if what I'm going to have happen is I'm going to set begin to to int time.time at the very beginning. Okay, so the purpose of this is just to give it an intro time. And then instead of just having it time.sleep for a second, I'm going to have it constantly be updating and reading the value of the actual time. Now this will give us a much more accurate countdown because the amount of time between seconds, it'll be reading if a second has passed and then updating every time it reads that a second has passed. That's what I want. Okay. Now, do note here, now, drat. I don't want this to be an integer. I really don't. I want this to be time.time. Okay, and then instead of this, I want timer to be time.time, well, the integer of time.time minus begin. Okay. Although I really don't want this to be here, I want this to be begin equals time.time. So it'll just reset. So if it detects a rising button push, it resets begin to the current time value. Okay, and then down here when we update timer, I'm going to want timer to not just change by 1. Timer is going to be equal to, now here's where we got to be a little bit weird. I want it to count down from 90. if I wanted to count up from 0 to whatever value it is, then I would do it like this: time minus begin. Okay, so this would be a count up timer that would count from 0 upward. I don't want that. I want it to count downward from 90. Okay, so I'm just gonna put this in here, and then I'm gonna say int 90 minus the amount of time that has transpired. Okay, so now it becomes a countdown timer from 90. If time.time is equal to begin, or very close to begin, then it starts at 90. Now, I am not really certain what value this is going to put out. So I'm going to go ahead and print timer. And then I'm going to go ahead and actually time.sleep for 1 second. Okay. This is probably not the best way of doing this code, but I'm just doing this for check purposes. Okay. False is not defined. Does it have to be all caps? False is not defined. Does it have to be like this? Yes, it does. 89. So it starts at 89. Yuck. I'm going to go ahead and stop that. This starts at 89 because time.time minus begin, apparently a little bit has transpired there. So what I'll do is I'll go ahead and change this to maybe 1. And then I'll have this sleep for 0.2 seconds. Run it again. I'll stop. And you'll notice that it does in fact start at 90 this time. Okay, so just little things that you can do to change your code. I'm going to remove the time.sleep, and I'm going to remove the print. And what I'm going to do instead is I'm now going to make it so that the time can't go negative, because I don't want the time to be negative. So if timer less than 0, timer equals 0. Now it can't go negative. Okay, and then I'm going to go back up here, run through this again, check the timer value. Go back up to this again, check the timer value. Yeah. So this is my code. Okay. If you have any questions, feel free to email me, set up a time where we can meet. I will always walk through your code. If you're planning on building this, I will want you to produce a video. It would be nice for you to show me your code. But I really, really want to see your thing operate. I want to see the button push actually doing something. Okay. Otherwise, if you're writing a report, it's due next Friday. In fact, a video of you using your device that you built, or a report will be due next Friday. Okay. We'll be done with this class next Friday. I've had somebody ask me about what it would take to get an incomplete in this class. Incompletes are an option. I'm looking into it. I'm not a huge fan of it because it means both I and somebody else have to do work over the summer. But this coronavirus thing has caused a lot of problems, and some people went back to work. And that was necessary for them, so I will be forgiving, and I will try to figure out an incomplete.
If you would like to do an incomplete for this class, let me know, send me an email. I will try to deal with it when I get it. Alright, this is the last lecture that we have for this class. It's been fun. It's been very much pain. I enjoy doing this Raspberry Pi stuff, and I really wish that we had more time to do it. I encourage you to experiment with your Raspberry Pi over the summer. For those of you who are taking 350 in the fall, as of right now, it does. I have received some notification that it seems we will be having in-person classes this fall. That may change. I really hope it doesn't. I want to see all of you, and I feel like education itself will be significantly improved in person. But I am planning on teaching 350 with a Raspberry Pi. We're going to do some fun stuff with the Raspberry Pis, actually build some control systems. So bring your Raspberry Pi to school next year. You're going to need it. For those of you who I won't be seeing again, have a good rest of your life. It's been a lot of fun knowing you. Good luck.